In this video, we are going to look at homework 4-9, day 1. So if you please could open that up. And we had talked about question 1 and 2. So I would like to take a look at question number 3. It says Augustine's body metabolizes caffeine at a rate of 13.5% per hour. So the amount of caffeine in Augustine's body decreases by 13.5% per hour. So if I take 100% and I subtract off 13.5%, that means that 86.5% is left. So that would be our day or hourly decay rate. So it says here in part A, if Augustine consumes a cup of coffee with 90 milligrams of caffeine in it, how long will it take for Augustine's body to metabolize half of the 90 milligrams? So if we think about the fact that our starting value is 90, and we are going to a finish value of 45. So that's kind of what we want to think about. So our formula for this particular situation, you started out at 90, you're going at a rate of 0.865 every hour, okay? So we want to know, when is that going to reach 45? So first thing we got to do, you got to divide both sides by 90. So we get 45 divided by 90 is 1/2. And then that's going to happen every single time when it says, when is it going to be half of what it was? Okay. And so remember, this is our base, this is our number, this is our power. The power is always equal to the natural log of the number divided by the natural log of the base. So let's use that to help us. So our power, which is an h, is going to be the natural log of our number 1/2 divided by the natural log of our base, 0.865. Now I'm just going to type that into iMath so that it can, it can do that hopefully and understand what I mean. So I'm going to type in the natural log of 1/2 divided by the natural log of our base, 0.865. And I'm going to let them do the calculation for me. And you will see we get that right. Now, in the first question, it went from 90 to 45. In question B, it's going to go from 186 to 93, but you're still going to get this exact same thing. This will always be 1/2 in that situation. When is it going to be a half? So it would still be the natural log of 1/2 divided by the natural log of 0.865. Now, let's say that it is some arbitrary figure C as far as the milligrams of caffeine. If we have half of it, 1/2 of C divided by C is a half. So it's going to be a half every time. So the main idea, what they're telling you, is in the situation, if 13.5% happens every hour, or it goes down, decreases every hour, you are always going to get the natural log of 1/2 divided by the natural log of our base, 0.865, every single time, no matter what our starting value happened to be. So that's kind of what that question is getting at. I think I must have typed something. Oh, I forgot a parenthesis there. I think we're okay now. Okay, so that's kind of what they were getting at for question number 3. Now at this time, if we could jump to question number 5. It says a 7-ounce, okay, let's start again. A 7-inch sunflower is planted in a garden, and the height of the sunflower increases exponentially, increasing at 15% per day. Let's talk about the function for the sunflower. Now, what we know is that f of t is our starting amount. Now, if yours is not 7, use your starting amount. 100% we're going to add on. It's increasing by 15%. So let's use the decimal 1.15 t. So that is for my particular sunflower. That is my formula. Now, it says how many days after it is planted will the sunflower be 28 inches tall. Now, remember, our input is time, so we want to know when is the time going to be, or what is the time going to be, when we are 28 inches. So when our function is 28, so the formula is 28 equals 7 times 1.15 to a power of t. Now, unlike the last equation, we do have this number sitting here. Oh no, we had a number sitting there. We do need to divide that off, just like the last one. You always want to divide that into your final value. So if we divide by 7, we get 4 equals 1.15 to a power of t. And so if we use the same thing, that our power is going to be the natural log of the number divided by the natural log of the base, we're going to get that. So in this case, it would be the natural log of 4 divided by the natural log of 1.15. Now it says, how many days after will it be 133 inches tall? Now remember, if we think about the fact that the only thing different is in this case, we want to use 113. So let me write this down and then I'll scooch it up here a little bit. So 113 is 7 times 1.15 t. Now 113 is not perfectly divisible by 7. So I'm just going to leave it the fraction. So again, this is my number, this is my base, that is my power. So my power is always the natural log of the number. I'm just going to write it as a fraction, divided by the natural log of the base. So it is the natural log of the number, 113 divided by 7, whatever the heck that is, divided by the natural log of my base, 1.15. Let's see if I entered something wrong. The natural log of 113 divided by 7 divided by the natural log. Let's see, what did I do that they can't? Well, it says the natural log of 113 divided by 7. How many days after it was planted will the sunflower be 1? Oh, because I can't read, it's 133. This is hot. Go. So I'm going to make that a 133 and a 133 and a 133. Oh, I need to get new glasses, I'm thinking. There you go. Now let's jump to question 7. It says Jack plants a magic beanstalk that is 6.5 feet tall. The height of the magic beanstalk increases exponentially, tripling each day. So let's think about the fact that if day 1 we start at 100% and it has tripled. So, if it started at 100%, if you multiply by 3, you'll find what it is each day. So our function would become 300%. And so we would do the starting amount, 6.5 in my case, times 3 to t. So let's put that in there. So we got that. Now it says, if the moon is directly over the beanstalk, how many days after the beanstalk was planted would the beanstalk reach the moon? Okay, so some things. All of our measurements are in feet. The moon is 238,900 miles, and every mile is 5,280 feet. So the distance we are talking about is 2,300. 238,900 times 5,280 would convert all of that to feet. So that's the distance we want to go, whatever that multiplication is. Don't care. We're going to let iMath do some of that. So we want to know when this whole thing, 238,900 times 5,280 will equal 6.5 times 3 to the power of t. So we need to see, get rid of that 6.5. So we have this gross number divided by 6.5 has to equal 3 to a t. So remember, it is going to be the power, the thing we're looking for, the time, is going to be the natural log of that disgusting number, 238900 times 5,280 divided by 6.5 divided by the natural log of 3. So let me make sure I wrote that down right, given the way I've been going here. 2389005,280. Yep. Okay. Excuse me, let's try that. Okay, so, okay, so what did I do wrong? There are so many miles. There are 5,280 feet. 23890. The natural log of the number divided by the natural log of the base. Let me see if that. Oh, maybe that's what it needed. There we go. Sorry, make sure you always put your input into your logarithm in parentheses. I didn't. Yeah, okay. Now, if the sun is directly over the beanstalk, how many days after the beanstalk was planted would the beanstalk reach the sun? So you see what we typed in for B, the only calculation that is different. So I'm going to select all if it lets me. I am going to copy and I am going to paste it. But I'm going to take out the 238,900 and I'm going to replace that with how many miles it is to the sun. So that'd be 92,960,000. And I think we should be okay. Yep. So there is question number 7. And finally, let's look at question number 9. It says at the beginning of 2000, Nuka's house was worth 222,000. CJ's house was worth 112,000. At the beginning of 2003, Nuka's house was now worth 188,000, and CJ's $156,000. Assume what the values of the both houses vary at exponential rate. It says write a function to determine Nuka's house. Okay, so remember, it is always going to be the starting value, which, because it's going to be in thousands of dollars, we don't have to include the thousands. So the starting value is 222. The ending value, do you see how it has gone down in value? It was in 2000 worth 222. In 2003, it was worth 188. So it would be 188 divided by 2000. or 222,000. We don't have to put the thousand. And then our that is a 3-year growth, so we need to divide that by 3. Okay, so 222 times 188 divided by 222 to a power of, in parentheses, t divided by 3. Okay, I think that should be what they want. Now it says write a function that determines CJ's house since the beginning. So exact same thing for CJ's information though. So for CJ, it's going to start at 112, and then 112 divided by 156, and then t divided by 3. Oh, I'm sorry, wait a second here. I have to put the final value on top. The final value for him is 156. The starting value is 112. Divide by 3 because it's a 3-year growth. Okay, so 112. Boop, there we go. 156 divided by 112 to a power of t divided by 3. And then it says how many years after the beginning of 2000 will Nuka's and CJ's house have the same value? Okay, so let me hit enter. Make sure my equations are the same. So we could put our equations into decimals. We could, but technically we're looking where will 20, this equal this. Okay, so let's get the t over 3 things by themselves. Okay, so we're going to get the t over 3 things to one side and the numbers to the other. So it's going to be 222 divided by 112, and then it's going to be 156 over 112, all divided by 188 over 222 to the t over 3 power. Now I know this is very convoluted, so I'm just going to do a little trick I call big C over little c. So the outer 2 will multiply and go on top, big C. The inner 2 will multiply and go on the bottom, little c. So I'm going to have 156 times 222 on top, 112 and 188 on the bottom, all to a power of t over 3. Now we can do exactly what we did before. We need to solve that for t. Now I'm going to show you what's going to happen. We would get that t over 3 is the natural log of the number divided by the natural log of that base. But because of the fact that 3 needs to go where it belongs, we're going to put that 3 in front. We're going to enter all of that junk into iMath. So I am not going to do the math. I'm going to let iMath do the math. They did not say to simplify, so that means they can accept my big old disgusting fraction. Okay, so the natural log, 3 times the natural log of 222 divided by 112 divided by the natural log of 156. That was not 156. Wait a second here. Okay. You know what I was typing. 156 times 222 divided by 112 times 188. So I'm going to let iMath do the work. And if you look at what I've got here, if you look right there, it does match what I got right there. Okay, so I think we're good. So that is homework 4-9, day 1. There you go.